Good evening to everybody. My name is Timothy. I'm the chairman of TMR Programming Consults. Today is another day. That will be day 7 of our lecture. Today marks April 29, 2024. We shall continue our lecture. Tonight, we shall start the calculation right from the comparison of machine learning and deep learning together. So, our tutor, over to you, Ayobami. Please, let's
Okay,
start.
okay, sir. Good day, everyone, from everywhere we are from. So I want to um, tell us that we're going to go into the coding aspect proper. So, but this time, what we are trying to do is we are trying to compare the difference and contrast between deep learning and machine learning. So, what we're going to do tonight is that we are going to pick a data set and we are going to use machine learning algorithm and we are also going to use a deep learning architecture. So, now I'm going to share my screen and I'm going to show us what we are trying to do. So, well, before we go ahead, there's something we are going to use tonight. So, we are going to be using Google Colab, and there's a specific reason for that, which I will let us know later on as the class progresses. So, I think everyone can see my screen. So, I'll be sharing my screen, like I said. And okay, I think my screen is sharing. So now this is what we want to do. So we have shared two notebooks on the group chat, and the two notebooks are actually talking about the Boston housing data set. So, and what is there is actually this is that we are actually looking at the Boston housing data set, and which is a common data set used in regression task to predict housing prices based on some various features, so to say. So, but we want to use a deep learning model to solve the problem because normally it is a regression problem. So, but we want to use deep learning. So, but now, what before I go into the deep learning aspect, and I'll just go to the machine learning aspect. So, normally, the ML boosting focus on the traditional machine learning technique, whereby we use the housing data set to predict prices. So, now the theoretical foundation there is that there's a machine learning model that is being used. So, and we can actually use different machine learning models, like we have talked in the machine learning recap, where we can use linear regression, decision tree, or example methods like the random forest or gradient boosting machines. So, and also feature selection can also be done. So that's selecting the most informative features from the data set to improve model accuracy and reduce overfitting. And as well, cross validation, like we lay emphasis on that feature selection as feature engineering is very important. So, and we talked about the cross validation is just used for assessing how the result of statistical analysis will generalize to an independent data set. So now I'm just going to look at something tonight. We want to look at how the code works. So now we'll do data splitting. So the data will be divided into training and testing sets to ensure the model can generalize well to see new or unseen data, and we'll that's after importing the data, we split it into train test, just like you said. So the model training, which we use different algorithms that apply to the training data. So for
Can you
instance,
try
a decision
to
tree.
zoom out your screen, sir?
So the model training, we can use different or any type of algorithm that we want to use that best suits the features that we actually selected. And hyperparameter tuning, so just adjusting parameters like the depth of a tree or the number of trees in the forest to find the best model configuration. And the performance measurement using metrics like R squared or mean absolute error to evaluate model performance on the testing set. So that's what we are going to do for the machine learning aspect on the boosting housing data set. So now going to the deep learning aspect. So the theoretical foundation is that deep learning models, so they are typically artificial neural networks with multiple layers that learn to represent data with increasing levels of abstraction. So now for a housing price prediction task, a neural network might learn features directly from the data, such as relationships between the size of a house and its price. And also, we are going to look at, because we talked about layers in the last class, yeah, we'll talk about layers, loss functions, optimization. So the layers, the common layers in such models includes the dense, which is the fully connected layers. So the dropout layers for regularization and activation layers, like the ReLU, so which we actually talked about. That's different activation functions. So that we have, so which ReLU is part of it. So and we have loss functions. So the model might use a mean squared error loss if the task is regression, aiming to minimize the difference between predicted and the actual housing prices. And the optimization. So technique like gradient descent, specifically its variants like Adams or RM's RMS prop are used to update the weight of the model to minimize the loss function. So we'll see this in the code as when we get there. So, well, we just want to look at how it works before we go into the coding aspect itself. So now the data processing aspect is like inputting data like the number of rooms, tax rate, etc. So it's normalized or standardized. Then the model building. So layers are stacked to create a deep neural network architecture. So and the training. So the model learns by adjusting its weight, just like we looked in the last class, based on the back propagated error from the predicted versus the actual prices. Then the evaluation. The model's performance is evaluated using metrics such as the root mean squared error. So we don't want to talk too much, so we should just go into the coding aspect properly. So this is what I'm going to do. So I'm going to go to Google. So I will search for Google Colab. Say Google Colab Collaboratory. Yeah. So I'll just click on this. So now, as you can see my screen, so I'll just click on Google Collaboratory. So I click on that. It's going to bring me to this place here. So, but I can open a new notebook. So you can see. So now Google Colab, what Google Colab does is this: is that it helps you host a Jupyter notebook, and it allows you to have free access to computing resources. So, including GPUs and TPUs. So, and it's well suited for any machine learning, data science, deep learning task. So, and it's very good. So it allows you to, to build your models very fast due to the resources is there. So, and if you want to open a new notebook, you can just click on new notebook. So I'll click on new notebook, and I'll wait for it to actually come up. So it's loading, as you can see. Okay, so okay, now here, so here we have it. So this is the Google Colab environment. So as we can see here. So now there are things I'm going to show us around this Google Colab. So I use it a lot. So and the reasons why I use it a lot. So when I don't want to waste time, building models, because sometimes there are some codes you run on your Jupyter notebook on your local machine that will take time. So and you don't want to waste time, because you need resource or you need to save time and save resources. So then you just come to Google Colab. So it helps you compute very fast and build your models very fast. And one of the reasons is that it depends on your RAM size. Yes, your RAM size and your hard disk space also determines some things, and the spec of your system also determines. So if you are using 4 gig RAM and you want to build a deep learning model where you have a very big data set, then it should consume more resources on your system, whereby it will be hanging. So it will not, it will not give you room to do any other things, and it will slow up the time to build up the model. So if you are using 8 gig RAM or 16 gig RAM, so you can still do that, build your models on your local Jupyter notebook. So, but if you know that you have a lot of a lot of softwares that shares resources on your system, and you want to compute very fast, so you just go to Google Colab. So it really helps. So yeah, this is the environment. So I just want to show some things how it works before I go into what I want to do. So basically, this is the way it works. So we have here file. So here we can locate any Jupyter notebook in your Google Drive. You want to locate anything in your Google Drive, you can. So which I'm going to show us. So I want to locate anything in my Google Drive, I can do that. I can click on locate. You can see. So it can take me, it will take me to my Google Drive, but you must have actually, linked your Gmail with it. So here I have some notebooks. There are some works I've done. So all the work I did on Google Colab, it automatically saves it on my Google Drive. So I don't have to, worry about losing any work. So it comes here, it saves automatically in this place here. So that's that. And if I want to open it, I can open anything I want to open. Can open it. For example, let me just open this. So I right click, I'll say open with. So you can see what I want to open with. So Google Collaboratory. So I click on that. So it's going to open. So just waiting for it. So it gives me room to, okay, it's loading. So now I have this. So this is one work I was doing. So this is just showing me something I've done. So I was training a deep learning model here. So you can see, so this is showing me the train loss, validation loss, stuff like that. So now this is just one way of doing of saving your work. So anything you do, it saves right here on your Google Drive. So you can have reference to it anytime you want to have reference to it or load it. So that's that. Now, another way is this, is that from your Google Drive, you can actually open a Google Colab notebook. So I will click on new. So if I click on new, let me do that again so we can see it. I'll click on new. So if I go to my Google Drive, then I will go to more. So if I go to more, so I will see Google Collaboratory. But in some certain cases, we might not see Google Colab here immediately. So that is for some people that have not actually connected the Google Colab to their drive. So what you do is that when you click on new, so you go to more. So we want to assume that Google Colab is not there yet. So and we want to put it there. So all you need to do is just go to connect more apps. So if I click on connect more apps, so it's going to, I'm waiting for it to come up. So it's now going to give me preferences to different apps I want to have access to. So then I can search for the app. So there are a lot of apps that are here. If you want to connect with your Google Drive, so that you can, anything you do there, it saves directly to your Google Drive. So I will just search for Google Collaboratory, which Google Colab. So if I start, okay, let me see. I think collab will be nice. Collaboratory, yeah. So if I search for collaboratory, then I'll wait for it to load. Just take some moment. So now if I look for that, okay. Now the reason it's not showing here for me is because I already installed it actually. So these are just other things that different. So, but it's telling me that I already have this installed. You can see it here. So I've installed it. So I don't need it. So I'll just close this. So after you install it, you come to new, then more. So I have Google Colab. So if I click Google Colab, it's going to take me to Colab, Google Colab directly. So that's the second way of going to Google Collaboratory. So the first, so you can see in Google Colab now. That's accessing it through your Google Drive. So another one is just going directly to Google Search, using Google Search Engine and type Google Colab, then you load it from there, just like I showed us. So, and okay, so there's one more thing I want to show us. Okay, so now another one is this. Now, for example, if let us say you're having issues trying to work with a particular Jupyter notebook, and you don't have time to waste, and you want to complete very fast. So you can just come here and click on File, and you can click on Upload Notebook. So if I want to click on Upload Notebook, so I can upload notebook from, you can say, from my Google Drive. So if it's on my Google Drive, I can access it through there, or from GitHub. But if it's from your PC, so you can click on Upload. You can say Browse, so I say browse file. So I can browse the file and pick whatever file I want to pick. So I'll just use this for reference sake. So let us, okay, so just come here. Then let me just click on this. So I'll click on open. So now it's going to upload it. It's going to open it for me. So that's, you can see. So this is this here. So that's way of uploading the notebook and trying to work with the notebook using Google Colab. So now another thing is that we can rename. We want to rename this. We can rename this. We want to rename. So and also if we want to save a copy in the drive, save a copy as a GitHub gist, or save a copy in GitHub, or we want to download it after we are done. We can download it using two extensions like the IPYNB extension and the .py extension. So if you want to download the notebook as that, so you just click on download, then it downloads it as that. So that's that one. Then we can edit, and what is there is just that there's no much difference between this because we have this edit, the view, the insert, runtime, almost looking like the local Jupyter notebook that is being installed on our PC. That's when we download an Anaconda navigator and we install. So that's that about that. So now, not to waste our time. So there's something I want to show us again. Okay. So now, if we want to do something here now, so I'm clicking on this. Okay. So I want to do. So now there are. If we want to choose some sample data, we have some sample data. We can actually, um, have access to those data. Yeah, some sample data. I want to use the sample data. There are some sample data that are always attached to this, so if you want to work. So and also we can locate it from the drive. If you want to, but let us say you have your data in your Google Drive. So maybe the data is very heavy and you have uploaded it to your Google Drive. So let's say data of let's say 2 gig, 3 gig, or 4 gig file, and you have uploaded it to your Google Drive. So you can mount your drive here so that you can have access to the data there instead of you downloading, the data, or so maybe if it is in a particular drive, so you can just mount the drive. So you just click on mounting the drive, so you can mount it here. So let us just dismiss. Let us go to what we want to do. So I just click on this. So I don't want to do this. So because so from Google.color import drive.mount. So I don't want to mount my drive. So let me just close this page. So let me go back to where I came from. Okay.
Some people have been raising hands.
Okay. So if you have any questions, so please ask question before I go into what I want to go into proper. Please.
Olubumi, Olumide.
Hello, if you have question, please. Now is the right time
You
to
raise your
ask the
hands or
questions
Please,
before
can
we
you
move
please
forward.
expand your screen, please?
Okay.
okay, that is observation.
Hello?
Hello, that observation. You would have said that in the message, so I would have told him straight. Okay, can you please expand your screen?
Yeah, I've done that.
Okay,
So,
yes, it has been done. Any other question, please? Any other question? Okay.
Please, can you please expand your screen?
Okay.
Hello?
So now there's something I want to show us now. So how to use this environment. For example, now, so we have this cell colon. Yeah. So for us to use this cell, this code cell, we can say how do I say? Um, let's create a variable.
Excuse me, sir.
Yes.
Okay, sorry for the interruption. I just want to make reference to the man that asked the question earlier on about you expanding your screen. If he is satisfied, maybe at his own end, maybe he's finding it difficult to expand from his own end. Maybe Mr. Timothy could just verify.
What I'm seeing here is very clear. The recording is very
Yes,
clear.
I'm talking. Yes, the man that asked the question, if he is satisfied, maybe he needs to do the expansion from his own end.
Okay.
You could just tap the screen and the thing will just expand.
Okay.
You can continue, sir.
Okay.
Thank you.
So I just want to show us how to use this environment here. So I just created this variable. So and if I want to run this, it's either I use Shift Enter, which normally works the way it works in the Jupyter Notebook environment, which is installed on our system. Or you can press this play. So you press the play button. So then it's going to show us that it has run. So just wait for it. So now you can see it has run already. So but now so there's something. If you want to add another code cell, is either we use this code cell here. If I click on this, it automatically adds another one. Or if I want to do it, I can use this to add more. So if I bring this my mouse to the middle of this code cell, I can add another one below. So if I want to add a text, I could add a text here, and I'll just double click. I'll just say deep learning. So then I have it here. So and that was just it. Just say shift enter. Then I have it. So deep learning, you can see. So if you want to write any notes or do some explanation, just the same way it is on the local Jupyter notebook that is being installed on our PC. So you can see yeah, I can use the print function, print training. So if I run this, so it's going to print deep learning from scratch, just this. So just trying to show us around. So and that's just this about this. Yeah. So but we can delete this cell. We want to delete. I want to delete this cell. I can delete this cell. Can move up a cell. So and you can move down as well. Anyone you want to do. So now enough of the jamboree. So let us move to the real deal. So now this is what I want to do now. So we want to upload the notebook we want to use, and I'm going to upload it just now. So I'm going to browse. So we're going to deal with the machine learning aspect first. Yeah. So we're uploading it. So if you have any question, please you just have to ask immediately, so we can clarify everything. So now what we want to do this
Ask your
night
question,
is that
please. You can interrupt and ask your question, please. Mr. Ayo, Ajayi.
All right, thank you very much, sir. I just want to ask if we can use other programming languages on Google Colab, like R programming, and and Julia on Google Colab? Is it only Python we can use on Google Colab? Thank you.
Okay. So as far as I know, as I now, so it's Python that I know that is being used on Google Colab. So, but
Okay.
if it is the local Jupyter notebook, yeah, there's a way you can integrate R on the local one. That's yes on that one. And there's something I noticed of recent. The recent update on the Anaconda Navigator, it now has some features that looks like this Google Colab. There are some features that look like Google Colab. Now, it has a console, a terminal, just like this, a console. You can see a code snippet like this. It has a command palette and it has terminal. So I don't know if anybody noticed that update. It's not that it is an update that when you have installed it will update itself. I mean, you download the recent Anaconda Navigator update, then when you install it, maybe you uninstall the previous one you are using and install the current one, the updated one, then you see all those features. So R can work on the local one. But I don't know of this, but there's a way it can be done if maybe through connecting through an API or whatever it is. But so far as I'm concerned, for Google Colab, it is Python. That's what I know about
Thank
Google.
you.
Okay, sir. So is there any other question before I move ahead? Okay. So this is what we want to do now. So we are trying to do something here. We want to build a machine learning model. So and to do that, first of all, we need to import some libraries that will help us with building the model. And the first thing is NumPy. And NumPy is numerical Python. So allows us to be able to manipulate any numerical values, maybe it the integer. So and also we have the pandas, which allows us to actually help us manipulate data frame or a data series. And we also have the matplotlib, the pyplot, and which allows us to be able to build appealing visual graphics. So ranging from different ones from the histogram, the pie chart, just name it. So, and we also have import warnings. So, and like I said, the import warnings allows us to suppress the warnings that might come up. So we don't want anything like warnings to come up. So we tell it to just ignore. So just suppress it down. So, and after that, we are going to run all of this now. So we are running this just now. I run this line of code. So we just want to see. So import NumPy as NP, which is the alias. Import pandas as PD, which is the alias.
Can you zoom it more? Can you zoom more? So that will be much bigger. Yeah, that's good. That's good. It's okay.
So we have all these. We have run this already, so it has run. So now, up to the next one. So what is this about? Yeah. So there's something that I want us to know. Now, from scikit-learn, which is popularly known as an sklearn, so we have some data sets, some standard data sets that we can use to practice and to train. So, and in that data set in sklearn, there are some data sets that are there. For example, Titanic data set, you can find it there. You can find the Boston housing data set. You can find the a lot of data sets are there. So and we said from sklearn import data sets. So now we name that data the data set we want to actually we are interested in. We created a variable for it. We said Boston. So Boston is equals to which is from data sets. We said data set dot load underscore Boston. So which means that the data the data set we actually just to be able to import it. So instead of I know normally we are supposed to like say boasting is equals to pd.read_CSV, right? Is that not what we are thinking? So we put in brackets something like this. I think we are actually looking for something of this nature. I will say boasting is equals to as pd.read_CSV, where we have something like, okay, we have boasting underscore, let's say housing, okay, then dots, say dot CSV. So this is what we're actually looking for. Now, this will actually work in the case whereby we don't want to use an existing data set. Like let's say like the one that is in scikit-learn now is a standard data set. So we can use them just to play around, to build models. They are standard data set, they are readily available. So just imagine maybe we have our boasting housing data set as a CSV file, as an Excel file. So what we would have done is that we would have click on file and we would have upload yes, we'll have upload or mount a data set. So we'll have done that. Come in. Would have done that from here. Would have just done that from here. So we would have said upload or say new file. You can see that. So we say new file. So we just click on new file and it will allow us to upload the data set. You get what I'm trying to say? So, but we are not interested in that. So, but what we are dealing with is that we already have our data set. So, and that's what we're going to do. So we are going to run this. Let's wait, please. It's trying to load. Delete this. Okay, I think we're having an error. Let me rerun it again. Sorry for that. Try and rerun this again, please.
We have less than 5 minutes for this class to end now, and I'm going to share you another link to join us again.
Okay, I think this is what I'll do. So let me just restart.
No, but the code is being underlined, which means that there must be something there.
Yeah, I understand.
We have not run the NumPy pandas and
yeah, we have run it. So this is it.
No. Yeah. I think maybe remove the load busting thing and then leave the dots there. Maybe it will give you some idea of what functions to call.
I'm coming. So just let me see. Okay. Yes. Can you sort this out now? Okay. Just trying to do something here. I'm coming, sir. So we'll sort out just now. Coming. We run this first. Okay. Let me add another code cell. Insert this. Okay, I think this is the issue.
The problem is from that load busting. Delete it and leave the dot and see the ID will give. delete that load busting.
I'm coming, sir. Just let it come here. Let me do this first. It's part of. I wanted to display the error. Something I want to see. So I should just show the error. So the error might give me what is wrong. So because if I remove the load boosting, it won't give me anything because we have a lot of data sets there. So let
No,
me
the point
just
is
do this
if
one.
you remove it, it might give you a list of functions that you can call. Remove that one
Data
too.
set. Sure.
Put the dots, put the dot at the front and see
I'm
what
coming.
happens.
Okay, I'm coming. That's it. So it's now it's going to do that's it. Okay, so there's something. Let me check this place. Maybe it's I have for now test train. Okay, next. Okay.
You can recall your already prepared Python code and run it, and let us see the results.
Okay, I'm coming. Oh, posting. Let me see this. Still giving issue. Posting.
I think we needed to load some libraries on the Google Colabo. If the libraries are not loaded yet, it will not run.
No, the scikit-learn. Okay, I think I'm coming. Okay, just give me one moment, please. Okay, so we have breast cancer, diabetes, iris dataset. Okay, so one. So these are the ones. Okay, the issue there is this is that okay, and this one are the only available. These are the only available ones here. So which is
Yeah.
diabetes data, digits, files, iris. Now okay, sample image, sample light. These are the ones available. So you just please, okay, this is what I'll do. Just give me some moment. I need to get the posting housing data. Those are just, that's the issue I'm having. Yeah, so what is there is that it's supposed to be actually there.
Can I share data with you? That posting housing?
Yes, exactly, sir. So I think I have it here. Just 10 variable 506 observation. 6 observation. Okay. Think I have it. Okay. This is it. Just download it from here. Downloaded.
This will end in the next 2 minutes. So
go to this place.
I will share with you another link to join now. This will end in the next 2 minutes.
This is the data. So I already have the data. Yeah, so we just import it the normal way. That's all we just do that. Let me go back to the notebook. So, but this is what I'll do. We'll have to upload. I have this here. Okay, so this is it. So I've uploaded it. So I'll come to this place here. So I have my drive already. So since I've mounted my drive here.
So sorry, instructor, I want to say something to be
okay, sir.
Okay, so from what this experience now, because everything you did was correct. I've actually checked on normal Jupyter. Everything you did worked. Even this thing, if you print, you can print the data and everything. So, and even when you check that time, you see that function was not in Google Colab. So, which means that Some things that are available in normal Jupyter might not be available on Google Colab. Is that a lesson you think one can draw from this experience?
Yes, sure, sir.
Okay. Thank you.
And
Okay,
also,
so this is what I'm
in
going to do.
addition, for the fact that Google Colab has benefit of high speed when you are dealing with a very loaded data set. One of the demerits it has is just that you must be online before you can use Google Colab. Your data, your internet must be very strong. But unlike the Jupyter Notebook or Python, you don't need to be online before you make use of them. You can be offline and be using them and they work. So that means anything that has merit also has demerit. So the merit of the advantage of Google Colab is that it may work very fast, very faster when you are dealing with very large data sets. But the demerit is that you may not see some functions when you are doing at the time you are doing it, or perhaps you may experience a delay in loading data set if your internet is not strong. And also, your internet should be available whenever you want to use Google Colab. Otherwise, it will not work. So the choice is yours. Let's continue, please.
Okay, sir. So let us run this again. So we have, I don't think we need the just to load this.
Why don't we go
So I'm trying to
and do all
anticipate.
this work in a local machine instead of coming to this place?
I have my reason. So, but which when the training continues, you see the reason for.
Okay.
Yeah.
Uh,
Hmm.
so let's see this. Comment, please. So that this. So I'm coming. Copy the part. Okay. So we have the posting data set here. So it has been loaded. So let us put posting dot head. So which we'll see now. So this is the data here. So and part of the thing why I said Google Colab is very interesting is this is we can view. This is giving us suggestion to view some recommended plots. Now there are some recommended plots it will show us for each of the features. You can see it. So it's just showing us some plots. You can see them. So instead of you trying to find a way to write code for that, so you don't need it. So you can just choose some of the recommended plots to see how they are distributed, whether they are normally distributed or not. So which we can see from here. So, but I might not be interested in that. So I just want to let me see. Let me just see. Okay, let us see the shape of our data. Sorry, what do we call our set? We call it boosting. Then we call it boosting controls.
Should be boosting the ship.
Yeah, shape,
Remove data.
exactly. Posting.shape. So we have it as this 506 by 14. So, and if you look, I want to look at the posting.features. So this will give us that's posting.feature. So it's not a good feature. I'm trying to look for, okay. Okay, so I don't think we need, this. Just remove this. So we already viewed the head the other time. So I think let's say posting.head. Do not call it data frame. So posting dot. So we already look at the shape. So now this is what I want to do. Okay, I think we have price here. So we're going to check what we have here. We have age, tax, ratio. Okay. Sorry, please. I want to check something here.
One feature names.
Okay, sorry, I'm trying to.
Okay, we have it already.
I'm trying to look for. Okay. I think let me try and do something. Yeah. So I'm doing posting.describe. I want to see how its data looks. And we have the crown index. Just want to see. Okay. Now start. Click down value. Comment please. Go to the front. Trying to do some comparison, please. Come in. Okay, I think I already have what I wanted. So here's what we are going to do. So see, we have the data this way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 columns. So now we already described it. So and which we have all our, sorry, let me remove this here. So this is showing us the head of the data, and this shows us the description showing the summary statistics, showing the count, showing the mean, standard deviation. So this shows us that there is no missing value for everything. So now this is what we are going to do. What we want to do is this: is that we want to now look at the target variable. We want to choose a target variable. So, but here in the previous data, we have price here, but our price is going to be given as MEDV, so which is the median value. Yeah. So I'm going to put that here. So what we'll do here is we are not using the F, we use both capital BOST. Boosting, okay, and EDV. Okay, that should be it. So let's run this first. It's going to give us an error. Attribute called target. Okay. So it isn't coming. So try and compare this with this. The target. Okay. So let's just remove this. So let's remove this as well. They did the description already. Okay. So okay, so we want to look at the information of the data. So we have boosting.info. So this so we don't have any missing value. So we have 506 entries. So this is all we have here. So now the next thing is to now specify the target variable and the features I want to use to train our model. So this is all we do. So we want to specify now. So this is what I'm going to do. Yeah. So we are not going to use this. I'm going to just use boosting. Y is equals to boosting, and we just grab this MEDV. So we just grab this. So we have it here. So now boosting all of this. So I'm going to put every other thing. I'm going to put it there. So putting age, and putting and look at stop. Okay, let me just come to this place and copy it. Let's put this.
It's like you are talking to yourself. You are not cheating again because all these things you are doing.
No, I just want to populate features. So that's what I'm trying. Like I said this is this is the target variable. So this is just the feature that I want to use. So all these are the features. So which I'm just
You
trying
could
to
have
like
been
put
saying
them
it
in here.
so that people do not know what you are doing can hear what you are saying.
Okay,
But the flow
so
is
that's
going
just
in
what I'm
that
trying to
direction.
do. So which I'll do now in no time. So just I'll finish it just now. So comment please. Sorry, it's I think there is an error here. Let's care of error. Sorry for boosting. Start. And okay. Sorry, please. So let's load this first. So yeah, okay, good. So let's come to this place. Coming. So to see again.
I think you have a prepared
Okay.
note already. Why can't you use that note you sent to
Uh,
me that time?
okay. If I'm to use this one that is here outrightly, the result we are going to get. So I'm just trying as much as possible. Okay, I think this is what we'll do. Okay. Okay, let me just use this to explain. Then I will send the one I'm doing now on the Google Colab. I will send that the
Sorry,
updated code.
instructor.
Yeah,
Okay,
I'm
can I ask?
listening.
Okay, if I understand what you're trying to do, you're trying to select the feature variables, right?
Yes, sir.
Okay, so if that is the case, the posting data is a data frame, is it?
Yeah, sure. It's a data frame.
So I think you can use some of those data frame slicing things to select them from the full data.
From 0 to
You know,
okay.
I know it's not easy to always remember, but I think that is the best way to do that.
Okay. So I think okay. This is what I will do. This is what I will do. So okay, just to save our time. So this is what I'll do. Let me use this to explain. So then tomorrow I will just update that. Yeah, has been done. So I'll try and update that. So and this is okay. Let me see when we stop. Okay. So now what we are trying to do is that we are trying to just all these are going to be our features basically. So and the price, which is the MEDV, pertaining to the data set, the new one that we uploaded on the Colab. So it's the target variable. So and we are now going to specify. So that is the tag. The rest of the data apart from the median value. So and what we are going to do is that this we are going to import a train test split because train test split allows us to be able to split our data into the test size and the train size. So here, what we try to do is that say from SK blend of models underscore select test split. So now if you have X train, X test, Y train, Y test, we are specifying it. And from the SK blend of model selection, we said that we imported this train test split, and that's what we're going to use here. So the train test split, we will now call the two variables that we created where we chose the feature and the target. We have X and Y, which is this here, we call it here. And we now say the test size should be 0.2, meaning that we are using 20% of the whole um, data should be test size. So meaning that 80% is going to be used to train the data. So that's the 80% is for the train. So while the 20% is for the test. So well, some people do use 0.3, but most especially it's common to use 20% for testing, and while the rest is which is 80% is used for training the data set, the model rather. So now this random state, now what this random state is equals to 42 does is this. In the case whereby you want to run the code again, like the whole notebook again and again and again and again, and the value will not change. So what this random state 42 does is that when you are using the train test split function, it allows us to pick it picks some, it will not pick it uniformly, like starting from the index 0, it now picks up to, let's say, 300 for the training. No, it will pick it, it will shovel it together. So it will shovel it like, okay, it will pick the first index as train, and the 16 index as train, and the 300 index as train. So it picks it randomly, shovels it that way. So now, since it has shoveled it, and we want to run the whole notebook again, it will not lose that information. So it will still like just pick it, just the way it has picked it earlier on before. So that's just this random state is. So it allows us to like when it picks the when it shovels and pick the data points that it wants to use for the train test, so it still maintains it that way. What it picks earlier on before it runs it, that's just the way it will be. That's what the random state is for. So here now we're going to see the X train, the shape of the X train, the shape of the X test, just to see the amount it has picked for it. So to show us that it's okay, pick 20%, then picked 80%. So and for the X train, we have the feature to train. For the X test, we have the feature to use for the testing. Then and the Y train is the one we use for the training phase, and the Y test use the one for testing. So which is shown in this instance here. This is the result. So, but yeah, since this is a linear regression problem, whereby we want to predict the price of the house depending on some certain features. So we import from sklearn linear model, we import linear regression. So which is a model in linear model. So we have some other ones. So we for us to be able to call it conveniently, we just use LR is equals to linear regression. Then we now say linear regression dot fit X train and Y train. So which we want to use to train the model. So should be able to fit a model for us. So then after that, then we now have Y predict is equals to linear regression dot predict using the X test. So the remaining one that we saved to test the data, if actually it can predict on seen data. So now one thing there is that this prediction now, we will now compare it with the Y predict, we compare with the Y test to see to be able to predict the accuracy. Maybe it's actually being able to predict based on the model we have built based on the unseen data. So what we said it should do is that we plotted the Y test and the Y predict together. So and here we are able to see the true values versus the predicted values for the linear regression. So which is this here, we have the predicted value, which is here. So and which we can see from this place. And here we also have the metrics so that we can see the accuracy. So we used the mean squared error and the mean absolute error here in this case here. So which is actually peculiar to a linear regression model, mean absolute error. So which in this case we have the mean squared error is 24.29. So that's to 2 decimal place, and for the mean absolute error we have 3.19 as to 2 decimal place. So and if we want to compare it with the deep learning aspect, which is here. So what we try to use here is we try to use CNN here.
Sorry, instructor, please.
Okay,
Sorry.
sir.
Can you go back to that graph again and what you plotted against what the predict? Go up to the code. Let's see. Let's just understand. Here, it's okay. So the Y test
And the Y predict. Yes, sir. So what we try to do here is that we have the Y test and the Y predict. So which means that we are trying to we want to plot a scatter plot. So what is scatter plot? A scatter plot, we have X. This is just our X. So that means Y test is on this place here, on this axis here, you can see. So and we have Y predict is going to be on the Y axis. So and we say the Y test. Okay.
Okay. Now these are two Y values.
Yes.
Right?
Yes, sir.
But from what you're explaining, one is along X axis, one is along Y axis. Is it not?
Yes, sir.
Then, but I thought what you're trying to do is you're trying to compare the two, the predicted result and the actual result, is it?
Yes, definitely, sir.
Then in that case, both of them should be on the same axis. Why the whatever thing that they are based on will be on the horizontal axis?
The thing there is this is that if we were to do that, and this is the way it will have been. So the reason for doing it this way is this is that number one, we know that we have the Y test, which is the unseen data. You agree. So now the Y predict here now is the prediction that is based on the X test, which is the unseen features. So it's just like
Yes.
saying that based on these unseen features, that we want to put the unseen features inside the model that has been trained.
Yes.
So now there will always be a result for that,
Yes.
which is the Y predict. So now, since we already have the Y predict, now the Y predict is the prediction based on the model, based on that feature. But
Yes.
mind you, we have the Y test, which is
Yes.
actually corresponding to the X
To
test.
that, the actual
To
value.
that.
Yes.
Yeah. So now, since we have that, so now what we want to do is that we want to compare the two together to see,
Yes.
okay, if truly that this value coincide with this value. Yeah. So that's what we want to do. And the only way to do that is that if you look at this here, we use a scatter plot. Now, the reason for the scatter plot is that it's just going to show us in such a way that we want to get, it's just like, let us say, for example, we want to plot two features that have the same value. You understand what I'm trying to say? So, and if we want to do that, it will make sense if we plot them on different axes, because if they are the same value, it should give us a straight line. You get what I'm trying to say, sir? So it should be able to give us a straight line. And an example of that is this. Let me try to comment.
Yes.
So
you're right.
Give us a straight line. I'm just trying to. So it should give us a straight line, but in this case here, it's not giving us, because it won't actually give a straight line, because it is a model. Though is not going to be perfect. It's not going to give us 100% accuracy, which is not possible. So based on some certain things. So that's why we actually did that by plotting the Y test.
Axis.
Yes, and this thing on different axes, so that we will, had it been, it predicted perfectly, just like 100%, it should just give us the points straight away. So based on the each values for the X test. So that's just the thing there, sir.
Okay. Thank you.
So the other one for the deep learning, what we did was we actually used
We have
CNN.
less than 2 minutes for this class to end.
So we
can start the deep learning probably what it is tomorrow. So let us entertain questions. Because this is about 10 minutes to 10.
Okay, sir.
Do you have any question, please?
So can we just use the opportunity and continue with this machine learning part? So now you've gotten that result, which shows that the perfectly or near perfect agree with the actual result. So what next?
And what next is that we can actually do feature engineering again. So to see which feature we can remove away that is not actually contributing to the model itself. So we just delete that one. Or we can create another feature that can help the model. So those are just the things. Or we can do hyperparameter tuning. That's also another thing again that we can do, we can consider. So those are just the things that we can consider, because basically there are some, or we should check if some features are left skewed or right skewed. So maybe that might be the reason why some of the features are not contributing. So maybe we try and normalize them. So we try and normalize some of the features that are not. For example, I think we saw something of such. think when we were looking at recommended plots here, you can see some of the feature. You can see this. This one is left
Yeah.
script. You can see this one too as well. But this one is even more like bimodal or something. You can see this one as well. So this can actually help us to actually maybe we should normalize this. Try and normalize this as well. We should try and normalize this also. So based on that, we can have a better model with better accuracy, and we can use some other feature apart from the root mean squared error, just like we chose, or and mean absolute error. So maybe we can use other metrics to check for the accuracy, something like that. So that's another way.
Okay, if I don't know whether other people have question, so that it's not let me. Otherwise, I want to ask another one. Okay, so now I know we are just so.
All right, thank you, sir. My question is, how can we interpret the mean square error and the mean absolute error? The figures we are saying there, how can we use that to determine or to evaluate the quality of the model or the result produced?
Okay, that's very simple.
Thank you.
You see, when you are comparing different models, different algorithm, the one that produce the least mean square error value is considered as the best among them. And likewise, the one that produce the MAE value is considered to be the best.
Okay.
Yeah.
That's the least, right?
The least, the minimum, the least, the smallest value.
Okay.
Because mean square error means is to measure the efficiency of the model. That's the smallest value. That's the error. It's like you want to measure 3 students and you give them essay to go and write the essay. So if you see student A has 20 error, student B has 15 error, student C has 10 error. So the best among the 3 students is one that has the least error.
Okay.
Which is student C.
Okay.
Thank you, sir.
Follow up. Right. Okay. I don't know if another person has a question. Let me ask. So, instructor,
yes,
I want to ask. I know this is just a class, so you want to teach deep learning. But the point is, if you have a problem in practice, you won't just go to deep learning if there is, because what we actually want is actually efficient solution, which is something that is fast and accurate. So if you have machine learning, which is easy and can give you the better results, can give you a good result, so no need for machine learning. So my question is, what actually, for this kind of problem now, what will motivate the use of deep learning?
Okay, the motivation behind using deep learning, or rather than machine learning. Yeah,
exactly.
We have less than 2 minutes, please. Let's talk fast.
So the reason is this. The reason is this. Like you have rightly pointed out, you said efficiency, and like we have looked at now, the least error. So from the result of the deep learning, so if you compare the value, the mean squared error here, look at this. Using a deep learning, you can see it is 11. So the machine learning for the mean squared error, you can see is 24.
Okay.
So which model do you think will perform better? Is it the deep learning one or the machine learning one? Based on that.
Of course, but the question is, the question is, in practice,
Yeah, you said in practice. Yes, I'm not done, sir. So I'm trying to still answer your question. So if it is the deep learning, that in practice, what is there is that when it comes to the fact that you want a better model, deep learning actually gives you the best. The reason is this: is that deep learning tends to uncover the pattern better than machine learning. That's one thing about deep learning. So that's number one. And provided the data is very big, provided the data is plenty, very plenty. So number two. So number two is
you say what?
I said the reason.
I'm listening. I'm hearing him. Let him continue. Let him continue.
Okay. So number two is that when we are trying to look at not only just accuracy now, when we are talking about the aspect of comparing, like when we have large data sets, like that. So deep learning is better. So it's to uncover the pattern better. So the second one also is the domain, the type of data also matters as well, even when it doesn't have to do with let us say the data is large or not. So the domain. So there are some domain whereby in health or in finance or this thing. So there are some particular models or architecture that are best used, that is even very good. So I think in the notebook for the machine learning recap, if you noticed, we talked about some models, some machine learning algorithms that are best used for some certain scenarios. When it comes to classification problem, we use some certain algorithm. When it comes to non-classification models, we use so and so algorithm. So it also depends. Yes, it also depends on that as well. The problem we are looking at, we also determine which type of architecture or algorithm we are trying to use. So those are just the two basic things. So
please, your question. Samuel Junior, your question, please. Samuel Junior, your question, please.
Yes, can you hear me, sir?
Yes.
Yeah, we can hear you, sir.
I want to add a little contribution on the algorithm, what you just said now.
Okay.
And you know, there's some algorithm that has to do with binary classification.
Yes.
There's some data set have like maybe fraud detection that have to do with fraudulent or not fraudulent. So that also have to determine the choice of algorithm to use. So, and I want to, I don't know if my contribution is accepted on the issue of deep learning and machine learning. I think deep learning work almost autonomously without any kind of, let's say, supervision, no supervision.
Yes, exactly.
Yeah, my own knowledge about deep learning. So, well, I'm a little bit, because I joined the class late. I don't know, maybe due to time, maybe some other time I'll ask, maybe tomorrow I'll ask the question I want to. I don't know if time will permit me to ask.
Yeah, you can ask the question, sir.
Okay, so what I want to ask is
let him ask tomorrow. We have less than 1 minute.
Okay.
Okay.
Less than 1
Okay, sir.
For the class to end.
Okay, it's okay.
Let's keep talking now to the last minute. Let's keep talking to the last second. Why do you want to close and disturb ourselves tomorrow? Let him keep answering.
Sir, this is this an intro to deep learning that you started with this Boston?
Yeah, we are not. This is not what we are trying to deal with. We are going to computer vision, dealing with images, a lot of things, building objects, character recognition, how to detect face, and those. That's where we are going. So we are just digressing little by little into deep learning.
Okay, you have not really entered deep.
We have not entered at all. Yes.
Okay, now on Google, on
Colab.
Kaggle, I think that was where you got this data set on. This
Yes. Yes.
Okay.
I got it from
now,
there.
how do you download it or import it from Kaggle?
No, I downloaded from Kaggle. Yes, it's there.
Sorry.
If you search for it, you just click on the download. After downloading, so I don't know if you are trying to ask how did I upload it into the Colab environment? Is that what you are
exactly?
Exactly. There's a way we did that. I think I explained. This was what I did.
And that was why I said I joined the class late.
I uploaded. I first of all uploaded it. This is it. I uploaded it to my Google Drive, which is this here. Okay. This is what I did. So. And I now come to the Colab environment.
Show you from Colab environment. Where you went.
And that's where I am. So now after I imported into my Google Drive, I now came here. I now mounted my Google Drive. So I'll click on mount. So if I click on this mount drive, it will create a code here and say it has mounted my drive for me. So me mounting my drive, so it's now allows me to have access. So my drive will be here, and I'll be able to see. You can see my drive, right? So this is my drive. So for my drive here, I'll just use something here. I'll just put this here. The name of the data set .csv, and I'll put forward slash there. So when I run it, it will just load the data set for me. So that's one way to do that, by using Google Drive. Or I can upload it like this, upload to a session storage. And this upload to a session storage means that when I am done, the data will go away. So if I come back again, I will have to upload it again to use it, because in Colab you can't store anything forever. So when you are done with that session, you lose anything that has to do with data sets that you use. So that's why it's best to upload your data in Google Drive or a cloud storage or anywhere it is, so that you can connect it with it, so then have access to use it. I hope I'm clear, sir.
Yeah, yeah, give him
So
shed light on it.
okay, so you can just click on upload the session storage here. So you will be able to upload it. You can see, just up.
Hello? Hello? Thank you very much. The class has ended.